Hello and welcome to 5.3 Rational Numbers. This will be some mini lecture and guided answers to the selected problem sets. So let's get started. Rational numbers. The set of rational numbers is denoted by Q, and the set of all numbers from the form P over Q, where P and Q are integers and P does not equal 0 because, as you just learned from the previous video, that would make a fraction where something is being divided by 0, making it undefined. So let's just get started by thinking of what some rational numbers might look like. They could look like 5 over 7, 0 over 2 because that would make it the fraction 0, 2 over 1 because that could be reduced as 2, but it's still a fraction in the form P over Q. What about 9 over 3? You could think that is reduced to 3 over 1 or just 3. 4 over 7. How about negative 3 over 2? How about negative 1? How about a negative 9 over 20? And a negative 1 over 4. These are all examples of what rational numbers might look like. Okay, so now we're going to look at actually reducing fractions. So the best thing to do is refer back to your multiplication rules. If you're pretty good at multiplying, then you're going to be pretty good at being able to reduce a fraction. So we have 2 over 4. Well, think of the smallest things that it can be broken down into. 2 is the multiplication of 2 and 1, while 4 can be thought of as 2 times 2 or 4 over 1. Well, if we think of 4 times, or 4 times 1, excuse me, we're not going to get very far because that's just going to reduce to 2 over 4 again. But if we think of 4 as the product of 2 times 2, think about our fractions where 2 over 2 will cancel out, leaving you with just 1 over 2, which is the reduced fraction of 2 over 4. If we're able to duplicate that same pattern in number 2, 3 over 9, just think of 3 as a product of 3 times 1, while 9 can be thought of as 3 times 3 or 9 times 1. 9 times 1 would not get us anywhere because the 1's would cancel out, still leaving us with 3 over 9. But if we think of 9 as 3 times 3, we can now consider the 3's canceling out on top, leaving you with just the fraction 1/3, which is the reduced fraction of 3 over 9. If we continue our pattern with number 4, that's 5 divided by 37. Think of 5 as the product of 5 times 1 over 35. Think that as the product of 5 times 7. What's going to happen here? The 5's will actually cancel out, leaving you with the fraction 1 over 7. And if we look at number 5, it looks a lot similar, except instead of a 5 as the numerator, we have 7. So let's break our fraction down just like we did number 4, where 7 is the product of 7 times 1 over the product of 32. Let's use the numbers 5 and 7, or 7 and 5. Well, similarly, the 7's will cancel out, leaving you with the fraction 1 over 5. Okay, and that was problem set 1. If we look at problem set 2, we're looking at mixed numbers, where mixed numbers look a lot like a number and a fraction. The best thing to do is to think of this fraction and the whole number as two different pieces being added together. So we have this 3/4 coming over here as 3 over 4 as a fraction, but what can we do with this 1? Well, remember with adding and subtracting, we have to have common denominators, and remember 1 can be written as any number over itself. So 1 can be written as the rational expression of 4 over 4 in this case, to make sure that we have common denominators between the two fractions. And what would that be reduced to? That would be reduced to 4 over 7 because we keep the denominator, but just add the two numerators together. And that will give us a mixed number. A mixed number will give us an improper fraction, meaning that the numerator is larger than the denominator. Now if we look at number 2, let's think about our two pieces and how we can add them together. Now I like to do stuff that keeps this improper fraction, or keeps the improper fraction has the same denominator as what we started with this one little fraction piece right here, which is 8. So we have to think of what will reduce to 8, what improper fraction will reduce to 8, or to 3, excuse me, where 8 is the denominator. Well, the best way to do that is just to write your denominator that you want to use, which is 8, to keep these the same, and just multiply it by that mixed number, which is 3. And what's 8 times 3? That's 24. So when you add 24 and 7 together, leaving 8 as the denominator, on top you're going to have 24 plus 7 is 31. Okay, and with number 3, what you're actually doing, you're given an improper fraction, and they say, give me a mixed number. That means we want a fraction where there's a whole number and attached fraction. So what can we do? The best method is to actually take the denominator and do long division into the numerator. So we're taking the 5 that was on the bottom and making it outside of the division symbol. So how many times will 5 go into 8? It'll go in 1 time. So you say 1 times 5 is 5. You subtract these, you're left with 3. And 5 will not go into 3, and we don't want to carry this any farther, so we're going to call 3 the remainder. Well, the steps now are quite easy. You take what could go into the full time, that was 1, and now you take the remainder, the 3, and you place it over the fraction denominator, which is the 5. Okay, looking at number 5, what we want to do is think of this in a lot similar case as we did the previous examples, where instead of adding, you're going to be subtracting, which in a way they will combine. So you're going to have, let's leave this 3/4, but instead of a plus, let's keep that minus in there. And with this -1, we want to keep our negative in, and now we want to write 1 as a rational expression where we can add these together, leaving the denominator as 4. And so we can use our rules and say, what's 4 times 1? That's 4, and that's going to be our denominator. So a negative minus, or a minus being subtracted, is going to give us a minus, according to our rules of subtraction. And there we do adding or subtracting. We have the same denominator. They have to be the same, so we keep it for the answer. And finally, -4 minus 3, that gives us a -7. There's a minus right there. So there's the answer. With number 6, let's do this in a lot similar way as we did before. Let's leave our negative out of the answer for now because we know it's going to be a negative anyways. So we have our negative. Now we just take that denominator and divide it into the numerator. We say how many times will 5 go into 8? It will go in 1 time. When we subtract these, we get a remainder of 3. So using this piece of information, we want to see how many times it went in fully, which was 1. Have the remainder written as a fraction, with the remainder being the numerator, and the original denominator being the denominator in the answer. And we will pick this up in part 2 of the video.